What is the total strength? Hello?
Hello?
Are you able to hear me?
Yes, sir. Yes, sir.
Yes, sir.
Sir. Yes, sir.
Voice is clear?
Yes, voice is
Yes,
clear.
Sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, Ramle, sir.
एक second, 1 second, 1 second.
Yes, sir.
Kindly wait for 2 minutes.
सर आवाज नहीं आ रही। हेलो सर, आपकी आवाज नहीं आ रही।
अभी आ रही है?
हाँ।
Kindly mute all. We'll start the class.
काय यार कळत नाही रे जीवन.
Good afternoon, everyone. Myself, Venkatramana. I am instructor electrical signaling lab, EDSET. Topic given to me is S18. S18 is the electronic interlocking system. Are you able to hear me? One person can reply.
Yes.
Yes, sir.
Yes, sir.
Okay, good. Okay. In railway, we're having different types of interlocking systems are available. Okay, that is mechanical interlocking, electromechanical interlocking, electrical or relay interlocking, and electronic interlocking systems. Uh, the era of interlocking started with mechanical interlocking. The era of interlocking started with the mechanical interlocking. Then mechanical interlocking, it has worked from decades. Okay. Then we have moved to next stage of interlocking, that is only electromechanical interlocking. In mechanical interlocking, we have some drawbacks. वो ड्रॉबैक्स को एलिमिनेट करने के लिए we have gone to next stage of interlocking, that is only electromechanical interlocking. Electromechanical interlocking also work for some decades. Okay. And when you are moved to mechanical to electromechanical, there was some advantages are there, and some disadvantage has been still continued in electromechanical interlocking also. And after that, we have moved to next stage of interlocking, that is only electrical interlocking or relay interlocking. When we have moved to electrical or relay interlocking, we have got some advantages compared to that electromechanical interlocking. And for that reason only, we have moved to electrical or relay interlocking. This electrical interlocking and relay interlocking also worked for many decades, and here also we're having some drawbacks. वो drawbacks को eliminate करने के लिए next we have gone to next stage of interlocking, electronic interlocking system. We have gone to next stage of interlocking, electronic interlocking system. Probably in present scenario also in railways, we're having electrical interlocking systems are available, electronic interlocking systems are available. Even some places we're having the electromechanical interlocking also may be available. Okay, almost mechanical has been eliminated, maybe available in some parts of railway, but we're having these are the evolution of interlocking in the railway system. Yeah, mechanical, electromechanical. After that, we have moved to electrical or relay interlocking. Now we are at the era of electronic interlocking system. Okay, whatever it may be, in mechanical, electromechanical interlocking, electrical interlocking, or electronic interlocking, we have followed the essentials of interlocking. We have followed the essentials of interlocking. Okay, we have followed on all the stages, we have followed the essentials of interlocking. Okay, as per SCM, we know that SCM's 1.82, it has mentioned what are the essentials of interlocking. These are the four essentials of interlocking. These essentials of interlocking we have followed in mechanical, electromechanical, electrical or relay interlocking. We have followed. Even it is electronic interlocking also following these essentials of interlocking. Actually, first of all, what is mean by interlocking? As per the GR, the definition of interlocking. Interlocking means an arrangement of signals, points, and other appliances operated from a panel or lever frame, so interconnected by mechanical locking or electrical locking or both, that operations must take place in proper sequence to ensure the safety. That is only the definition of interlocking. Interlocking is an arrangement of signals, points, other appliances. Other appliances means like gates, crank handles, okay, siding points, operated from a panel or lever frame, and so interconnected. They are interconnected. These signals, point, and other appliances are interconnected by mechanical locking, or by electrical locking, or by both, and their operation must take place in proper sequence to ensure the safety. That is only the definition of interlocking. And we know the essentials of interlocking. Essentials of interlocking. It is mentioned in the SM para 7.82. The first thing, what the essence one is, it shall not be possible to take off a running signal unless all points, including isolation, are correctly set, all facing points are locked, and all the interlocking level crossings are closed and locked against public road for the for the line on which the train will travel, including the overlap. This is the first essence of interlocking. Means it states that conditions. It states about the conditions before taking up the signal. It states the conditions before taking up the signals, like before take off the running signal, all the points, including isolation, correctly set. All the facing points are locked, and the points in the even in the overlap also should be locked, and any LC gates are there. That LC gates are should be closed. Closed. Then only it shall be possible to take up the signal. This is the first essential of interlocking. The second essential of interlocking says that after the signal has been taken off, it shall not be possible to move any points or lock bar on the route, including the overlap and isolation, nor to release any interlocked gates until the signal is replaced to on position. This second condition states that once signal has been taken up, it shall not be possible to alter the route. Okay, it shall not alter the points in the route. Not only points in the route, overlap and isolation also, and not to release any interlocked gates until the signal is replaced to on position. This states about the second essentials of interlocking. And third, its condition, third essential of interlocking, that it shall not be possible to take off at the same time any two fixed signals which can lead to any conflicting movements. Which can lead to any conflicting movements. That is the essentials of interlocking 3. It says that at the same time should not take any two signals, two fixed signals which are conflicting. That it says a essential of interlocking 3. And 4 says that wherever feasible, the point shall be so interlocked to avoid any conflicting movements. This says the fourth point, wherever feasible, the point shall be interlocked to avoid any conflicting movement. These are the essentials of interlocking. Essential of interlocking. This essential of interlocking, it may be implemented in all the type of interlockings. Okay. Now, what is a railway? Now, what is a policy? Which type of interlocking to be adapted? Okay. Now we have seen mechanical, electromechanical, okay, electrical interlocking, and we are at this era of electronic interlocking. Suppose if you want to establish a new station in between two stations or in any new line, if you want to if a new line is coming, in that we want to establish a new stations there, which type of interlocking to be adapted at that station. For that, Railway Board has issued the policy in 2016. The policy mainly depends upon the number of routes. Mainly depends upon the number of routes. Okay, number of routes, average number of routes. Here it is mentioned here, type of station, average number of routes, and type of interlocking to be provided at there. Here, normally based on the number of routes, up to 10 routes. Up to 10 routes, we should go for the electronic interlocking. Electronic interlocking up to 10 routes. 0 to 10 routes, we should go for the electronic interlocking type system. And in the station, if having 10 to 50 routes are available, 10 to 50 routes are available, then we should go for the electronic interlocking linked to signal control center if required. Suppose here in a station, if having routes are in between 10 to 50, then there we should go for the electronic interlocking only. That electronic interlocking it may be linked to signal control center. It may be linked to the signal control center if required. That is only CTC, centralized traffic control center is there. No, that is only signal control center are same. It should be connected to signal control center if required. Like that arrangement should be available in that stations. Okay, if the 10 to 50 routes, it should be electronic interlocking linked to signal control center if required. And if the routes are between 50 to 500 routes, if the routes are between 50 to 500 routes, then we should go for the electronic interlocking with distributed architecture and are object controllers. And are object controllers means here if the number of roots are in between 50 to 500 roots, we should go for the electronic interlocking system with distributed architecture. Distributed architecture and are with the object controllers. Okay, with the object controllers and are with the object controller. R means equivalent to object controller, whatever may be. Okay, here up to 10 roots, it will be the electronic interlocking. 10 to 50 roots, also electronic interlocking linked to signal control center. These two are the electronic interlocking with the centralized architecture. And if the roots are more than 50 to 500 roots, here also we should go for the electronic interlocking, but here electronic interlocking with the distributed architecture. Okay, up to 50 roots, it should be the electronic interlocking with the centralized architecture. It is not mentioned here. It means that it is a centralized type architecture. Here specifically, it is mentioned more than 50 roots up to 500 roots. It has mentioned that a distributed type architecture. It is mentioned here, distributed type architecture, and with or without object controller. This will be the between 50 to 500 roots. Suppose in a station, if having more than 500 roots, we should go for the here we are having two options. One is the root relay interlocking with metal to metal type relays, or electronic interlocking with the distributed architecture and object controllers. Okay, with and object controllers, like it is mentioned here. Means here more than 500 roots are there. Here we're having two options. Either we can go for the root relay interlocking with metal to metal type relays arrangement, or electronic interlocking with the distributed architecture. As per the as we're having option here, either you can go for that root relay interlocking metal to metal type. Okay, otherwise you can go for the electronic interlocking with the distributed architecture. Okay, based on the expertise available in railways, it may be decided whether we should go for the metal to metal type relays, or we should go for the electronic interlocking with the distributed architecture. Like that, we can decide. This is the policy which type of interlocking to be adapted at stations. Okay, have any questions on this? Okay.
Okay, sir. Okay.
Right, okay, good.
Okay.
Simple. It is based on the number of routes only, we should decide whether we should go for the electronic interlocking centralized,
Okay,
electronic interlocking distributed, or this is the policy. Okay. Now, already you know that we have seen that in railway interlocking, we are having different types of different interlocking systems are there: mechanical, electromechanical, electrical, and electronic interlocking systems. Okay, this is the mechanical interlocking. We know that mechanical interlocking was the arrangement in mechanical interlocking. Mechanical interlocking, we're having mechanically operated points are there, mechanically operated signals was there. These mechanically operated signals are all are connected to cabins. In the connected to cabins, in the cabin, these are connected to levers. Okay, and there is a interlocking arrangement in the lever frame itself. Lever frame itself, we're having the arrangement. This was the case in mechanical interlocking. In mechanical interlocking, the arrangements was mechanical operated points, mechanically operated signals, and this mechanically operated signals points, mechanical operated points are connected using rods, and signals are connected through wires. Like that, it will be connected to cabins, and the interlocking activity used to take place at the lever frame. Okay, like that, this was arrangement in the mechanical interlocking. Okay, and this arrangement lever frame, lever to lever locking was there in the lever frame. We are achieving interlocking at this place. Okay, and these are some drawbacks of this mechanical interlocking, like size will be more, it will occupy more space, and mechanically operated gears will request time, and a limited range of operation means the range of operation also very less for a mechanical operated gates. And there is a limited scope for centralized operation in mechanical interlocking. And by default, this mechanical gears requires more wear and tear, intensive maintenance, periodical overhauling is required. These are some drawbacks of mechanical interlocking. Then after that, we have moved to the next stage of next stage of interlocking. That is only the electromechanical interlocking. This electromechanical interlocking is a mixture of mechanical and electrical gears. This is a mixture of mechanical and electrical gears. And in what are the major changes in when you move from mechanical to electromechanical? The changes are just power operation has been introduced here. Power operation of signals, power operation of points has been introduced. And for implementing, doing this power operation, the rods and signal wires are replaced with the cables. Means through cables only, power will be extending. We are operating the motors. But in electromechanical also, some of mechanical levers has been continued. Okay. Whatever in mechanical interlocking, whatever the arrangements are there, same arrangements has been this lever and interlocking between the lever to lever frames that has been still continued in the even in the electromechanical also. And in mechanical interlocking, there is a rigid connection between the gear and the lever. But whereas when you move to electromechanical interlocking, there may be there may be not there is no rigid connection between the lever and the gears. Okay, for that in electromechanical interlocking, to control this lever and operations on lever, we have connected the circuit controllers and the lever lock arrangement. Lever lock and circuit controllers has been connected. The circuit controller we are using to detect the lever position, and lever lock we are used to control the lever position, because here we don't have any rigid connection between the gear and the lever. But whereas in mechanical interlocking, we have a rigid connection between the gear and the lever. Okay, to control that, here additionally circuit controllers has been used in electromechanical interlocking. This was the arrangement in the still means here in electromechanical, we have given the power operations, but still some mechanically operated levers has been continued, lever frames has been kept like that. Like that, whatever some drawbacks are in the mechanical interlocking, that has been continued in electromechanical also. But some of the drawbacks has been eliminated here, like range has been increased. There is when you have gone for electromechanical, centralized को भी जा सकते हैं. We can go for centralized operation also. But some of the drawbacks, whatever there in the mechanical, it has been continued in electromechanical interlocking also. Next, we have moved to from electromechanical interlocking to we have moved to electrical interlocking or relay interlocking. Here, the interlocking we are achieving using relays. For that only, this electrical interlocking we are calling as a relay interlocking also. Here, when you move from electromechanical to electrical, here that in the cabins, the levers and lever frames has been replaced with the two things. That is only the with the relays and the control cum indication panel. In when you move to this relay interlocking, in the cabins, wherever cabins are there, in the cabins, what we have done, mechanically operated things will be replaced with the relays and the control cum indication panel. The control cum indication panel we are using for operating the station and controlling the station. And this same thing, control cum indication panel will indicate the field conditions also. It will indicate the field conditions also. And the relays we are using for achieving the interlocking. We are using these relays. Normally, these relays we are keeping in the relay room, and this CCAP, control com indication panel, we are keeping in the SM room. We are, but we are all interlocking will be controlled from all the interlocking will be executed at the relay room, but it is connect. This relay room will be connected to CCAP. CCAP located in the station master room. From there only we are operating. But in mechanical and electromechanical, there is a lever to lever. There will be a locking will be there. Lever to lever, there will be physical locking will be there. But in control com indication panel, there is no rigid connection. There is no locking between the apparatus on CCAP. CCAP, whatever knobs or push button we are using, there is a physical locking arrangement nahi hai. But that locking we are achieving in the form of relays in the relay room. Suppose when you move to this relay interlocking, these are the advantages we have got it. Like centralized operation, long range of operations को जा सकते हैं, and compared to mechanical, electromechanical, this relay interlocking is very faster in operation, and we can go for the centralized operations को जा सकता है, and long range of operation also we can increase, and obviously sizes, building sizes also can be reduced, because in mechanical, electromechanical we are going for multi cabins, but here we can go for a single place. From single place only can be controlled here, and there is no wear and tear components in electrical interlocking, and compared to that mechanical, electromechanical, these systems don't require the intensive maintenance is not required. Periodical overhauling also not required here. Only periodical overhauling is required for certain relays only. Only for this track relays only we require the overhauling. For remaining relays, we don't require any overhauling. Once coral life is over, we can replace that entire system with a new system. Like that, your maintenance will be very less in case when you move to relay interlocking. This was the advantages of relay interlocking. And when you move to relay interlocking, what are the drawbacks are there in the mechanical, electromechanical? All things has been eliminated. Okay, all these things has been eliminated in the when you move to the relay interlocking. And here, what are the drawbacks of relay interlocking? The relay interlocking में drawbacks क्या है? Normally, relay interlocking also initially we have gone for the non-root setting type or the panel interlocking type, and subsequently we have moved to the root relay interlocking or root setting type. We know that non-root setting type, to take off the signal, station master has to manually operate the points, and he has to take off the signal. Once signal has been taken off, then he has to once the train is received, to release the route also we have to do some operations on the panel. Okay, this was the arrangement in the non-root setting type. Okay, subsequently, to give the auto facility, we have gone to root relay interlocking. In root relay interlocking, by giving the command from panel, automatically points will be operated. And here also root relay interlocking, all points are operating at a time. To prevent this all points operation at a time, we are using the operation. We are use the chain operation. Using the chain operation, we are allowing points to operate one by one points operation. Like that, we have gone for the root relay interlocking. When you have gone for the root relay interlocking, to implement this automatic setting of the route, chain operations. Even after train receiving, also route release will be done automatically. To do these facilities, we are using more number of circuits. The circuits we are implementing use more number of relays. Then when we have gone for the route relay interlocking arrangement, obviously the relays has been become more and circuits are become more. The complexity has been increased. Relays also has been increased. And once the relays increase, the sizes also, relay room sizes, it will be compared to panel interlocking, it has been increased. And there are many drawings are there because more number of circuit, more drawings are there. And same time, any fault is there in the relay interlocking system, relay interlocking systems. Okay, the fault localization and fault rectification, it will take time. Fault localization and fault rectification, it will take time. And suppose if you want to do any installation, if you have to do carry out the installations, or if you want to do any alterations to existing systems, these systems will take the system will take more time because existing circuits we have to disturb and we have to carry out the work, and this will take the more time. This will take more time. Means here to disturb that existing circuits, we have to take the non-interlocking working, and during in the non-interlocking working only we have to do this all these activities. Okay, and modification is not easy in the relay interlocking, and here in relay interlocking also power consumption will be little bit more. Power consumption will be little bit more. Example, I can say that in British interlocking, if you see the British interlocking, suppose if the signal is not taken off also, some relays will be always will be in the pickup condition. Example like ASR relay will be there, and TSR relay, ASR, TSR, TLSR, TRSR, and point detection relays also. Point detection relay also. That NWKRs, NWKPRs, NWSRs, whatever it may be, point detection relays. Always we, in circuit we are proving this condition many times. We are energizing the more repeater relays. Here, in why the power consumption is more in here means here we have to prove the condition in many circuits. To prove this condition in many circuits, we obviously we require the more number of contacts. The more number of contacts we are achieving, we will get more number of contacts only by energizing the repeater relays. Here in more number of repeater relays we are proving, and the conditions we are proving in the different stages to make the system here safe in relay interlocking. For that, we having more number of repeat relays are there. Always it's once main relays pick up, repeater relays also pick up, and obviously some relays even the signal is not taken up, it will be pick up like that. These conditions, power consumption will be more. Majorly, your power consumption will be more, and installation is not easy. Faults or rectification is difficult. Like that, some drawbacks are there in the relay interlocking. To overcome this only, we have moved to the next stage of interlocking. And if you're going every stage, if you're going from one stage to other stage, we can overcome the drawbacks, or we can get some advantages in the new system also. We'll get some advantages in the new system also. Here, we have moved to the next stage of interlocking, that is only the electronic interlocking. What is electronic interlocking? Electronic interlocking system is a microprocessor based microprocessor based interlocking equipment that reads the field inputs and panel inputs. This is a processor based system. It will read the field inputs, it will read the panel inputs. Then after reading these field inputs and panel inputs, process them in fail-safe manner as per the logic available with the processor, and it will generate the required field outputs and panel outputs. It's a simple electronic interlocking system is a processor based system. It reads the field inputs, it reads the panel inputs, and after reading the inputs, it will process them in fail-safe manner. Okay, as per the logic available, with the system, and finally this generates the outputs. It will generate the field outputs and it will generate the panel outputs. Okay, it will generate the panel outputs. Okay, simple. Electronic interlocking system is a processor-based system. It reads the field inputs. How it will read the field inputs means, for reading the field inputs, it uses some hardware like cards, input cards or something cards will be used. Okay, for reading this field, it will use some input cards. For reading the panel, it will use some input cards. How the field conditions are read means, the field conditions it is reading using the field relays. Using the field relays, the field relay status will be read by this. Okay, and directly it will be read the panel status. And after reading these two things, and this will process the logic here. In electronic interlocking systems, there will be, we are using some softwares. In the softwares only we are writing the logic. That logic may be a system logic, or it may be a interlocking logic. Both will be there. This processor will, after reading these things, process the thing as per the logic available in the system, and this will generate the outputs. This will generate the field outputs, and this will generate the panel output. This will generate the field output means this will drives the some field relays. Okay, if the field relays are driven, according to the field relays condition, the field gates will be driven. Field gates will be driven. Same manner, this processor only will drives the panel also. It will drive the panel outputs also. We'll see later what is the field inputs, what are the panel inputs, what are the field outputs, panel outputs. Simply, this will read the condition of field. This will read the condition of panel. After reading the conditions, this will process the logic as per the logic available with system, and this will generate the outputs. I mean, this will drive the field gates. This will drive the panel. This will drive the panel. Okay, simple. This is a processor-based system. Simply, it reads the inputs. The inputs may be from field. The inputs from the panel. Inputs means inputs from the field. Inputs from the panel, and it will generate the field outputs, and it will generate the panel outputs. It will generate the panel outputs. Okay, this is another way of representation. Simply, this is reading the both the things. This is reading the field condition. This is reading the panel condition, and after processing, it will drive the field and it will drive the panel. It will drive the panel. Okay, simple. If you see the before going to discussion about the electronic interlocking, we'll see the relay, conventional relay interlocking. How was the how arrangement will be there? We know that in conventional relay interlocking, all our interlocking activity will take place in the relay room. All our interlocking activity will take place in the relay room by the relays. By the relays, the interlocking activity will execute at a relay room by the relays, and this relay room is connected with the things. What is connected? Relay room is connected with the SM room. In SM room, it will be SM room CCIP will be there. No? The CCIP will be connected to this relay room. And in the field, whatever gears are there, that gears also connected to relay room. That gears also connected to relay room. Actually, if you see the relay interlocking in the relay room, whatever relays we having, what are the relays we having here? Suppose in the relay room, we are having three types of relays. That is only the field connected relays, panel connected relays, and some internal relays also will be there. These internal relays, internal relays we are using for processing this interlocking, and processing this interlocking only. We are using some internal relays. Internal relays in the conventional relay interlocking. In the relay room, we have different types of relays. That is, the panel relays are available, and field relays also available, and we have the some internal relays also available. Some internal relays also available. Here, coming to in the conventional interlocking, what are the panel relays available? What are the panel relays available here? Okay, here when we are operating on the panel, to sense the panel status, in relay room, we are using some relays, all button relays. Normally, if button is available, a button relays will be available. If knob is available, then for that also to sense the knob position, we are using some relays in the relay room. That are the panel relays. So when you are doing any operations on the panel operations to sense the panel operations in the relay room, we are using some relays. We are using the relays. Suppose normally control communication panel. What control communication panel? Control communication panel consists of. It may be consist of push buttons, or it may be consist of switches, knobs or switches, or it may be keys, or it may be toggle switches, or it may the control communication panel consists of the indications also. Panel consists of indications. Okay, for doing to operate anything, either we are using this knobs or push buttons or keys or switches only we are using for controlling that things. When you are doing operations on the SEM room, the equivalent relay will be there in the relay. Equivalent every gear to sense that button or knob, we are having one relay is there in the relay room. That only panel relays. That here panel relays examples are when you are using push button, relays like GNR, UNR, WNR, LXNR, CHNR, okay, like GSBNR, RPNR, like that. These are the some panel relays, example of some panel relays. Like that, in the relay room, what is there? Relay room is the place where interlocking activity will take place in the relay interlocking. Here we are using these panel relays that to sense the panel status, and here in the relay interlocking itself, we having the some field relays also. Field gears connected relays also available here. Normally in field, we are keeping this equipment. What are the equipments we are keeping in the field? We are keeping the equipment signals, points, track circuits, LC gates, even crank handles. Like that, we are keeping the gear. These all gears are we are keeping in the relay room. The gears status will be repeated in the relay room. The gears status will be repeated in the relay room. Now here track circuit is there. Track for detecting the track position, we are using the track relay. The track relay will be located in the outdoor, but the track repeater relay we are keeping in the relay room. We are keeping in the relay room. Okay, why we are keeping the track repeater relay in the relay room? Because the interlocking activity will take place at the relay room. Okay, to do this interlocking activity, we require the track position. Okay, and like that, track relay and track repeater relay will be there in the here. Track relay will be there in the outdoor. Track repeater relay will be there in the relay room. And same here, point. If you see the point detection relays. These point detection relays are available in the outdoor. Point detection relays are available in the outdoor, and the point detection repeater relays are available in the relay room. Point detection relays are available in the relay room. Okay, right? Signal is there. So signal is there. Signal status relays. Signal which aspect is letting, whether red aspect is letting, yellow aspect is letting, or green aspect letting. To check that in the relay room, we are keeping the root lamp checking relays, that is RECR, HECR, DECR relays. We are keeping in the relay room. And same here, LC gate is there. Suppose LC gate is there. Then LC gate, how is LC gate status? LC gate status. Okay. Whether LC gate, LC gate is closed or LC gate is open. That status also, LC gate status relay will be there in the outdoor, and that repeater relay also will be there in the relay room. Like that crank handle position also, it will be repeated in the relay room. Crank handles, how the crank handles are there. Crank handles are whether in or locked, like that it will be there available in the relay room. Okay, and same time here, here in the field, we are having two categories of relays we are keeping. One is the field gear status relays, like that. If so far we have discussed now, how is the track, what is the track condition, track position, what is the point condition, what is the signal condition. Okay, how is the LC gate, whether LC gate is open or closed, how is the crank handle, like that. Everything means the status. We are using some status indication relays. How is the gear? What is the signal status? Okay, like that we are using some relays. Like these are the relays we are using here. Example for signal we are using signal status. We come to know through the relays ECS, RECR, HECR, DECR. This will indicate the signal status. If a root indicator is there, root indicator status will come to know through UECR relay. And point detection status. Point detection. Point is normal or reverse. For that, we are using some, in case of British, we are using NWKR, RWKR relays. Suppose in case of track, we are using the uh, uh, track repeater relays. TPS or the track repeater relays we are using. In case of LC gates, we are using the relays. We are using the relay name. Maybe railway to railway. The names may be changed, but that here we are using some LXR and LXCR relay we are using in the relay room to indicate the LC gate status. Here crank handle also we are using some relay CHR, CHCR, like that relays we are using in the here. Like that, these are the in the relay room, the field connected. Okay, field gear status connected relays also available. And in the field, what are the gears are there? To drive the gears, we are using some relays. To drive the gears, also we are using some relays. To drive the signal, we are using some relays. That is only half aspect control relays. To drive the signal, half aspect control signals, that is HR and DR. We are using for driving the signal. Suppose if you are having the three aspect signal, to control that three aspect signal, we are using three relays. Two relays, HR and DR. Suppose HR, DR both are drop condition. Using that relays condition, signal on aspect that is REC, red aspect will be lit. Suppose HR relay pick up, DR relay drop, then we are able to drive these yellow aspects. When HRDR both are up, we are driving the DZ aspect. Like that, to drive these field gates, okay, we are using some relays here. Like we are using some relays, okay, and in the same manner, point driving relays also is available. In the same manner, to drive the point also. Suppose outdoor point we have to drive. To drive the outdoor point, we are using some relays like NW or RWR, normal point operation relay, reverse point operation relay. We are using to drive the point to the required position. We are using some relays, and the system will never track circuits. System will never drive the track circuit, and we are driving the LC gate also. Means we are able to open the LC gate. Okay, we are able to open the drive. For opening the LC gate also, we require some permission. That permission or slot will get. For that also, we are using some relays. Some relay will be there in the relay room. If this relay picks up, then ultimately the repeater relay will be pick up in the in the near the gate. Then we are able to drive the gate. Okay, right. Next, we are using crank handle also. To drive the crank handles also, we are using some relays. Like that, in the relay room, in the relay interlocking field, for detecting the field gear status, we are using some relays. और फील्ड गेयर्स को ड्राइव करने के लिए वी आर यूजिंग सम रिलेस. पैनल स्टेटस को रीड करने के लिए वी आर यूजिंग सम रिलेस, and we are using some internal relays some internal relays. Okay, our interlocking interlocking will be processed by this internal relays, and this internal relays finally it will drives the field gears. The internal relays, what it will do, it will drives the field gears. If the field gears are field gear driving, it will energize the field gear driving relay. If the field gear driving relays are energized, then some circuits are there. That circuits will drive the all the outdoor gears. Whichever gears were there, that gears will be driven by some other circuits. Like example, internal relays finally it will drive the in case of British, it will drive the signal half aspect control as HR and DR. When HR and DR status using that status, we having some lamp circuits. Using that lamp circuits, we are driving the field gears. We are driving the field gears. Simply, this internal relays, once after processing this thing, this will energize this field field gate driving relays. Field gate driving relays condition, based on the condition, we are driving the things here. Example here for signal HRDR. Once HRDR are there, then we having some lamp circuits to drive the signal. And same manner here internal relays एक बार process करने के बाद this relays will energize the point driving relays. When these point driving relays are there driven, we have used some other circuits using that condition. We are able to drive the point condition. Same manner, this internal relays, once after processing, this will energize the LC gate slot relay. Once LC gate slot relay is pick up, the LC gate slot repeater relay will be pick up in the outdoor, and we are able to drive the thing here. Okay. Same manner, crank handle also, after internal relays processing only, this field gears will be driven, and the field gears driving relays will be pick up, and after that only crank handles driving relay or slot relay will be pick up in the outdoor, and we are able to operate the crank handles in the outdoor. Right, here we'll see that what are the relays available we in the British. I'm talking about British only. In the British, these are the relays, panel relays like GN, UN, UNA, GN, all panel buttons, knobs, connected relays. Okay, available. And internal relays, some internal relays are there. This is only processing the thing and maintaining the logic. We are using some relays like NRR, NNR, NLR, RLR, UCR, ASR, TSR, UIRs, OVSR. These are the like some internal circuits. You can treat like these internal circuits. And coming to field, we're having the status relays, signal status relay, point status relay, track status relay, and LC gate status relays, crank handle status relays like that available. And same time, to drive this field gears को drive करने के लिए we having some off aspect relays are there. Point को drive करने के लिए we having some off aspect relays are there. And to drive the LC gate, we're having some relays. To drive the crank handle, we are using some relays. Like that, we are in the conventional relay interlocking. Each and every function, we are achieving through the relays only. To do this only, we are using different types of relays are there. Okay. This is the arrangement in the relay interlocking. Okay, what we'll do, we'll take the break. Then after the break, we'll continue our discussion. Okay. Are you able to hear me?
Yes, sir.
Sir.
Yeah. Are you able to follow me?
Yes, sir.
I want response. Are you able to follow me? Nahi?
Follow, sir.
Yes, sir.
Yes, sir.
Okay. Suppose if you have any doubts, you can ask me also later. Okay. Thank you. We'll go for the break. Then after the break, we'll continue our discussion. Okay.
Sir.
Okay.
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, yes, yes.
Yes, sir.
Okay.
Yes, sir.
Just we have seen that in relay interlocking, what are the relays available? In relay interlocking, we have three types of relays are available. That is the panel interlocking relays and internal relays and field relays are available. Okay. My voice is okay.
Yes.
Yes, okay, sir.
Okay.
Yes, sir.
Right.
Yes, sir.
Okay. Good.
Huh?
We're having three types of. Okay.
अरे
Kindly
पूरा
mute.
सामान के घर घर पड़ा हो
Please mute. कीजिए please.
2017 का है ये। फिर ये
Who is?
के बाद उसका एब्सेंट वो है ही स्वीकृति दी गई।
ले लेगा वो एसी कॉपी चिपकाई हुई वगैरह।
Listen.
तो नहीं लेगा था।
Kindly mute all. Who is this person?
तो अभी लेटेस्ट में बना दो ना। नहीं लेगा फिर क्या होगा?
पूछो तो है
तो पूछने से नहीं, एक बार जमा हो चुकी है, बात सही है।
चलो लेके दे उनको ये सर्टिफिकेट
हरमनदीप सिंह।
17 का है और
हरमनदीप सिंह।
इसमें कोई
यस सर।
म्यूट आप म्यूट कीजिए कौन है इधर? Who is that? विशाल श्रीवास्तव।
सर।
म्यूट कीजिए। म्यूट।
विशाल श्रीवास्तव तो सर वो- अरे सॉरी सर।
दिलावर सिंह। म्यूट कीजिए। सॉरी दालवीर सिंह म्यूट कीजिए। म्यूट कीजिए। ओके सॉरी म्यूट कीजिए। दलवीर सिंह म्यूट कीजिए। प्लीज काइंडली एक काम कीजिए। कभी भी क्लास में क्या है, आप माइक ऑन किया तो आपको क्या कर रहे हैं सब मालूम पड़ेगा सबको। ओके। थोड़ा म्यूट करके क्वेश्चन पूछने के बाद अनम्यूट क्वेश्चन एक बार पूछने के बाद आपका आंसर होने के बाद म्यूट करके बैठिए। ओके ना? विल स्टार्ट आवर डिस्कशन। Okay. The relays used in the conventional relay interlocking are panel relays, internal relays, and field relays we are using. Okay, when you are coming to this electronic interlocking, okay, when you are coming to electronic interlocking, uh, when you're coming to electronic interlocking, in SM room, in SM room, along with CCIP, we are providing one more equipment that is called operator VDU. Operator VDU. When you are moving from conventional relay interlocking to electronic interlocking, what are the changes are there in the each? Well, in the SM room, along with CCIP, we are using one more equipment that is only the operator video. Video means visual display unit. This is operator visual display unit. It is it is the like a CCIP, control com indication panel, but it is a computer based thing. Means it is a replica of this CCIP. Okay, we are using this operator video. Means here to control the station, CCIP के साथ हम video भी use कर रहे हैं. Or otherwise, sometimes what we are doing in SM room itself, we are keeping two operator videos. Here in electronic interlocking system, for operating this station, either we are using CCIP and video, or otherwise we are using dual videos also, two videos also there. Then this why you are using two things for your means redundancy. Only for redundancy, we are using CCIP के लिए video redundancy, video के लिए CCIP redundancy. In case of dual video, redundant, one both are redundant. Suppose a working, one is not working, we can operate two other also. Like that, we are using these two videos in the electronic interlocking. When you are going to electronic interlocking in the SM room, what we are doing, the changes in the SM room, either we are going for CCIP and video model, or otherwise we are going for dual videos. Using these videos, we can able to operate the gears, and we can able to control the entire station, and the yard status will be indicated on this operator consoles. Okay, on operator consoles it will be indicated here. And coming to relay room, in relay room, what we are doing in relay conventional relay interlocking, we are using panel relays, we are using internal relays, we are using field relays. But in electronic interlocking relay, in electronic interlocking, all these relays we are replacing with the EA equipment and field relays only. Earlier conventional system, all the relays we are replacing with the two things. One is the EA equipment, other one is the field relays, same that are continuing like that only. A field relays means field status indication relays, field gear driving relays. Still, we are continuing like that only. Suppose when you are moving to that, and when you are going to outdoor, and then outdoor, we are not doing any changes. We are conventional relay interlocking was the arrangement. Same arrangement will be continued even when we are going for electronic interlocking also. Electronic interlocking को जाने के बाद भी outdoor there is no change. Only the change is there in the indoor only. That indoor also relay room. Previously we are using more number of relays. Now we are using the entire all the relays are replaced with the two things, that is field relays and equipment. And SM room, either we are going for CCAP and VDU, or we are going for the dual videos, whatever it may be, we are going for the operation. Simply the what is the electronic interlocking system? Electronic interlocking system is a processor based equipment which reads the field gears, and which reads the panel or VDU, whatever it may be. It reads the panel or VDU. After reading the after reading the field gear status, panel gear status, and it will process the logic logic and as per the logic available with the processor. And once the logic is processed, then it will drives the field gears and it will drive the field gears and it will drives the indications on VDU, indications on control com indication panel. It will drive the video and indications on control com indication panel. Okay, this is only system. Now I will take you to here. Normally, what are the components available in electronic interlocking system? Electronic interlocking system में what are the components are available in the electronic interlocking system? Are you able to see my see the diagram? Diagram आप देख रहे हैं?
Yes, sir.
Okay. Right. Now in SM room, what is there? We're having one operator video. Okay. In SM room, one control com indication panel is there. What is operator video? What is operator video? Okay. Operator video. Okay. Operator video is a computer. In that operator video, there will be one video software will be there. So that video software will be installed in the operator video. That operator video software is like a interface between the system and the operator. System and operator. And operator video software, the station layout will be there, and station layout there will be separate. There will be a buttons will be there. The buttons will be there. When the user is interfacing that buttons on VDU computer, means when computer is on and video application is open, when the user is interfacing that video software, this video software it will read the what operator is doing. After reading that operator status, the operator status will be sent to the EA system. The operator status will be sent to the EA system. And suppose from EA system any commands any control signal has been received, then this video software will display the indications. It will display the indications on the operator video. It will display the indication on the operator video. Okay. Operator video is a computer. On operator video, there will be an operator video software will be there. The operator video software will work like a interface between the operator and the system. Operator and the system. On layout, if any is doing any operations that will be sent, it will be sent. And according to the control signal from the system, that will display the status. Okay, we know that control com indication panel. Control com indication panel. Control com indication panel is there. Control com indication panel normally consists of buttons, knobs, keys, toggle switches, and indications, counters, and buzzers will be there on this control com indication panel. Okay, control com indication panel. Now coming to relay room. In the relay room, okay, in the relay room in electronic interlocking system, we having the relays. We having the relays. We have the relays, and we have this system. We have the system. This is the EA system, and these are the relays. Actually, field gears we are calling as a vital gears. We are field gears. We are calling as a vital gears. Why we are calling the field gears are vital relays? Because they are directly physically and directly connected with the train operation. They are physically and directly connected with the train operation. For that reason only, the gears available in the field we are calling as a vital gears. And the field gear relays only available in the relay room. Field gear relays only available in the relay room. That's why whatever relays are available in the relay room, we are calling that relays as a vital relays. We are calling that relays as vital relays. Here already we have seen that in the relay room, field gear status indication relays are there. Field gear driving relays also available. whichever relays we are using for indicating the field gear status to EA system, that relays we are calling as a vital input relays. That relays we are calling as a vital input relays. Okay, which relays using for driving the field gears, that relays we are calling as a vital output relays. Vital output relays. Here in the relay room, field connected relays only available, that is to indicate the field gear status. The relays used we are calling as a vital input relays, and the relays used for driving the field gears, that relays we are calling as a vital output relays. Vital output relays. In the relay room, these only relays are available. Coming to equipment, these are the cards are available. And same thing here, field gears we are calling as a vital gears, and other gears we are calling as a non-vital gears. This control com indication panel, we are treating this one as a non-vital gear. Operator video also we are treating as a non-vital gear. Okay. Now we are treating as a non-vital gear. Non-vital means it is non-vital gear. We are treating that as non-vital gear. Okay. Field gears only we are calling as a vital gears. Here, simple here, in the equipment, what are the components available? In normally one system, what are the components are available here? Every EA equipment consists of one CPU. CPU is the central processing unit. This CPU is the central processing unit, and within the CPU there will be a microprocessor will be there, and in the CPU only some memory will be there for storing this system related software, or otherwise interlocking related logic को store करने के लिए they having some memory. And here for processing this data, having some memory, and for storing that events and errors also having some memory. The memory may be, this memory may be any type. It may be a ROM type or ROM may be EPROMs or EPROMs. It may be any type. Simply CPU consists of processor, or the processor and some memory. In that memory only, the memory will be utilized for many other purposes, like storing the system related software, and for interlocking related software, for processing the data, for storing the events and errors, we're having some memory. This is the CPU consists of this, and other modules available in the system are, that is the vital input cards available. Other thing components available in one system, that is the vital input cards. These vital input cards are used for reading the vital input relay status. For reading the vital input relay status, these vital input cards will be used, and the system having some non-vital input cards also available here. These non-vital input cards used for reading the operations on the control com indication panel. To read the operators operations, we are using the non-vital input cards. Simply what this non-vital input cards it is doing, it is reading the non-vital input status, non-vital input status of control com indication panel. Will discuss later what is the non-vital inputs of control com indication panel, non-vital outputs of control com indication panel. Okay, and same here, every system consists of some output cards also. Okay, here to drive this vital output relays, some vital output cards will be used. Vital output cards will be used, and same to drive that non-vital outputs to the panel, there will be some non-vital output cards will be used. Non-vital output card will be used. In each system, generally we're having this type of cards only will be available. What are the cards available here is CPU, we having vital input cards, vital output cards, non-vital input output cards, non-vital input cards, non-vital output cards, and maybe power supply cards also may be available in each system. Every system may be having power supply cards also. Power supply cards also is available in the system. That is, power supply cards also available in the system. And here in electronic interlocking system, there will be one more VDU is available. That is only the maintenance VDU. That is only the maintenance VDU. This maintenance VDU is also one computer. This maintenance in this maintenance video also there will be one maintenance video software will be there. Okay, this maintenance video will be connected to CPU of the system, and this maintenance video just it is used for storing the events and errors of CPU. Suppose CPU inbuilt, every CPU will do that event logging. Event logging will do. Once after doing this event logging, the event logged information it will be stored in maintenance video. Maintenance video. Using that events, we can find the system health. System health, and it is possible to find the interlocking status, like that all these activities we can do from the maintenance video. Maintenance video ultimately we are using for the to know the status of system. Status means here interlocking status or system health status. To know that only we are using maintenance video. Whereas operator VDU we are using to operate and control the station. To operate and control the station only we are using here, and but from operations are not possible from maintenance video. The station cannot be controlled from maintenance video. Normally, this maintenance video will be kept in technician room. It will be kept in the technician room to monitor the system health. To monitor the system health, we are keeping this maintenance video in the technician room. Okay. Normally, maintenance video consists of one software, and this software only will be used for interfacing with the system, and the system data will be stored here in the maintenance video, and maintenance software maintenance video software, using that maintenance video software only we can see the system health and interlocking status activity. Like that we can do the we can monitor the system locally using this maintenance video. Maintenance video use karike we can monitor here. Now coming to control cum indication panel, already we have discussed this operator VDU and control cum indication panel we are treating as a non-vital gates, and here control cum indication panel, for connecting this control cum indication panel to CPU for interfacing purpose, we are using non-vital input and non-vital output card. Non-vital input output card we are using, and whereas for interfacing for connecting this operator VDU with the CPU, we are not using any non-vital input output cards, because CPU is a digital device and operator VDU also digital device. Both are connected. But here CCAP is a analog one. Okay, a conventional analog one. To connect this CCAP to the CPU for interfacing purpose, we are using the non-vital input and output cards. We are using the non-vital input and output cards. Here on like that, out in field we are divided the relays into vital input relays and vital output relay. In same on panel also, we have classified into two categories. That is the non-vital inputs and non-vital outputs. Non-vital inputs and non-vital outputs. Simple here, non-vital inputs means whichever we are using for controlling the station, for operating and controlling the station, that we are treating as a non-vital inputs. Like example, push buttons. Example like a push button. By operating the push button only, signals can be possible to take out, like push button. and a push button having two states, that is pressed state and unpressed. Okay, suppose in the same we are using switches or knobs. The knob may be having two position or three position. Okay, we are using one position for one operation. Okay, one for take up the signal, one for suppose in case of signal, one position for keeping the signal to normal position, one position for keeping the signal to take up the signal. Again, point also. Okay, operating the point like that. This knobs or switch also having the knobs and switches will be treated as a non-vital input. When you are operating this only, the outdoor operations will be possible. Okay, and same keys also available, like keys on panel. We're having different types of keys like SM key. Okay, right next uh, we're having emergency keys like uh, sub route cancellation key. Okay, like emergency point operation के लिए भी control करने के लिए maybe you're having some keys like that. All the keys, the key, when the key is operated, only that operations will be possible. Okay, na? This key status we are treating as a non-white. We are treating as a input to the system. Okay, push button status also we are treating as input to the system. Knob status also we are treating as input to the system. Okay, next other things here we having any toggle switches are available. Suppose any toggle switches are there in the button. Suppose toggle switch having two positions like that is make and break. Suppose using this make and break also we are doing some operations from the panel. Okay, these are the things, push buttons, knob, keys, and toggle switches. We are treating as a non-vital inputs, and other things which are indicating the whole interlocking status, that will be treated as a non-vital outputs. Here, like we are using this uh, indications. Indications will be treated as a non-vital outputs, and that indications. In these indications will indicating the interlocking status. Okay, and counters will be there. Counters and buzzers. Counters and buzzers also we are treating as a non-vital outputs. When you are doing any event, that will be registered in the counter. The counter also will be treated as a non-vital outputs, and buzzers also. When any failures are there in the system, interlocking any failures like signal blanking or otherwise point failure indication, any button stuck up indication like that is there. To indicate that status also, we are using some alarms, audio alarms. Okay, audio buzzers we are using, that will be treated as a non-vital outputs. Here on panel, when you are operating certain things, then to sense that panel operator status, whichever things we are using, that will be treated, that we are treating as a inputs to the non-vital input to the system. The non-vital inputs are push buttons, knob or switch, keys, and toggle switches. We are treating as a non-vital inputs. Okay, and indications and counters and buzzers will be treated as a non-vital outputs. Okay, non-vital outputs. Okay, simply here in the system, this non-vital non-vital input cards are there. No, these non-vital input cards are used for reading the non-vital things on the control com indication panel. Okay, like push buttons, knobs, switches, toggle switches. For reading that only, we are using the non-vital inputs. And non-vital output card we are using for driving the non-vital outputs on the panel. For driving the indications, for driving the counters, and for driving the buzzers. Normally, the indications when it will be driven means only CPU after processing the logic only these outputs will be driven. This indication will be driven. CPU after processing the logic only this counters will be driven. CPU after processing the logic only it will be buzzers will be driven. Means these outputs will be driven by the CPU. output will be driven by the CPU. Okay, when this when CPU drives this only, this will be appear on the control com indication panel, and remaining things whatever is there, we are using for operating purpose. We are using for operating purpose. Operating purpose whichever we have kept here. To read this, we are using non-vital input cards. Okay, to indicate the interlocking status, whatever we are using in the control com indication panel, we are treating as a non-vital outputs here. Okay, why already we have discussed that. Why these non-vital input output cards only used for connecting the CCAP means here CCAP is analog one to connect this thing here to digital system. Okay, in between for interfacing purpose we are using these cards. Simply the control com indication panel status will be connected, means here the non-vital inputs push button status will be connected to cards, and knob status will be connected to cards, and keys status will be connected to card, and toggle switches status will be connected to card. Suppose when the operator is operating this, the status will be sensed by these non-vital input cards, and after sensing the status it will send to the system. It will send to the system. In the same manner here, these vital input cards, the vital input relay status will be connected to this vital input relays. The vital input relay status will be connected to vital input cards. Vital input cards, after reading this relay status, this will communicate to the processor. This will communicate to the processor. Like that, control com indication panel status will be connected to this one, and field relay status also will be connected to this one. And in the same manner, operator video. When if suppose operator is operating through this operator video, the operator video status also will be connected to this. Like that, once inputs from field, inputs from panel, or inputs from the CCIP is connected to thing here, this will process the logic. Once it will process the logic based on the software available here. Normally we are using here two types of software in the CPU. That is only the system software, that is executive software, and interlocking software, that is only the application software. Here in the CPU, we are using the two softwares: executive software, that is the system software, and the second one is the application software, that is the interlocking software. Using these two softwares, this will process the thing, and once after processing the thing, the CPU will give the control signal to the output cards. Then output cards it will drive the relays, means it will energize the relays. It will energize or de-energize the relays according to the control signal from the CPU. Once these relays are driven, okay, then according to this relay condition, the field gears will be driven. Once the field gears are again driven, the field gear status will come again back to the relay room. And once the field gear status has been again changed, again this status will be read by these cards, and the status will be again sent to the CPU. And once this status again changed, the CPU will process the logic, and once after processing the logic, this will drive the things. It may be drive output field outputs, or it will be drive the panel or video outputs also. It will drive the panel or video output also. This is the system. Simply, electronic interlocking system consists of one CPU, okay, vital input card, non-vital input card, and vital output cards, and non-vital output cards. And there may be one more power supply cards also may be available. Okay, and other modules connect. What are the modules connected to this EA system? Are the operator video is connected. Operator video is connected, and CCAP will be connected, and maintenance video also will be connected, and the field gears are also connected to the system. Field gears are connected to the system. Now here in electronic interlocking system, apart from here, we are connecting some other things also, like we are connecting this external data logger also we are connecting to system. Normally, every EA system, every CEA system having internal event logger will be there. That event logged information, it may be stored in system, it will be stored in maintenance VDU, it will be stored in external device also. That is external data logger also. This data will be stored. Okay, to connect this EA system and data logger, in between for interfacing purpose, we are using the protocol converter. We are using the protocol converter. Actually, why? Because the CPU will store the data in one format, and the data logger will store the data in one format. This protocol converter simply it will take the data from the system, and it will convert to the suitable form to the data logger, and it will send to the data logger, and that data will be stored. Simply the protocol converter it will receive the raw data from CPU, and after receiving the raw data and which in which format the data is required for data logger, that convert into suitable form, and it will be sent to the data logger. Data logger will store the data, and same time data logger is doing one more thing, that whatever input output relays are there, that input output relay status also directly connected to data logger. Means here the input output relay input output relay status, it can be connected to system as well as it will be connected to data logger. It will be connected to data logger also. Means here this relay status will be logged. This relay information will be logged in CPU as well as it will be logged in the data logger also. In case system is not working, system is power off condition. I say in that case is also we can find this input output relay status from data logger. Okay, we can connect the input output status from data logger. Okay, now if we see in the diagram, here operator would is a digital device. This is CPU digital device. Both are connected using either communication cable, or it may be connected uh, using the optical fiber cable also. It may be connected through optical fiber cable also. It may be connected through serial communication cable, or it may be connected through Ethernet communication cable also. It may be connected anything, but whereas here control com indication panel and non-vital input output cards, they are connected through the signaling cable. They are connected through the signaling. This type of arrangement initially we are providing. The non-vital input output cards we are providing in the relay room, and CCAP we are providing in the SM room. The CCAP used to connect to this non-vital input output card using the signaling cable. Suppose when you are how the CCAP and non-vital inputs are connected means here the buttons status will be connected to card. Means here when you are pressing this button on the panel, this analog voltage from the CCAP will be extending to the non-vital input cards. Okay, suppose if push button S1 GN push button is pressed, through this S1 GN push button, analog voltage used to extend it to the non-vital input card, and non-vital input card it will be connected to one of the inputs. It will be connected to one of the inputs. Like that, analog voltages we used to extend. For connecting this CCAP and non-vital input output card, okay, in between the SM room and relay room, what we are doing, we are using the copper cable here. Copper cable we are using, copper cable initially, and the same time the field gears are there. Now the field gears are there. Field gear status. The field gears are connected to relay rack. How the field gears are connected to relay rack? By the copper cable only. By the copper cable only, it will be connected. This double arrow indicates that. The double arrow indicates that this is the physical wiring. This is indicates the physical wiring. Okay, this indicates that the communication. This indicates the digital data. This is the digital data. This indicates the physical wiring. As actually, physical wiring is there here from field the through signaling cables. The field gear status is coming to relay room. First, it will be terminated on the CT rack. From CT rack, CT rack will be connected to relay rack. In the relay rack only, we are placing these relays. Same here also. The relay status, we are connecting to non-vital input cards. We are connecting to non-vital input cards. Sorry, this arrow will be light. Okay, this vital input cards, vital input relay status will be connected to vital input card. Vital input card, after reading this relay status, this will this status will be communicated to CPU. This status will be communicated to CPU. Okay. Now, this will be communicated to CPU. Okay. Same here also. In between relay room and field gears, for connecting the relay room and field gears, we are using the copper cables. Copper cables we are using. Okay. And in between CCIP and CIU, for connecting the CPU also, we are using the copper cable. And for connecting this operator video and the system, we are using communication cable, serial communication cable. Maybe you are using, that is communication cable, Ethernet cable or optical fiber cable also may be used. Suppose suppose if you want to use optical fiber cable, this operator video should support. It should support the output of the operator video should will be connected to device that will convert to the optical fiber, and optical fiber signal data will be sent to this CPU. And near the CPU also we have to use one more converter, optical fiber to electrical converter we have to use. Like that, we have to use suitable devices at both the places for connecting the things. Here, initially we are using like this. But if you are providing the signaling cable between the relay room and SM room, suppose any surge voltages coming from CCAP to the system, this will damage the system. Okay. To prevent that one, in the next stage, what we have done, this non-vital input-output cards, we have placed in the one more equipment called panel processor. We are kept in the panel processor. Normally, this panel processor consists of following things. The panel processor consists of non-vital input cards, non-vital output cards, and processor. There may be also some processor will be there. Okay. This panel processor now in the next stages what we have done, the panel processor is placed in the SM room, and the panel processor and the relay room we are connected using the serial communication cable, optical fiber cable or Ethernet communication cable use करके connect किया. Earlier we are connecting the copper cable. Suppose if you are connecting through copper cable, there is a chances that surges may come from one place to other place, and it will damage the equipment. By using this here communication cable, both sides we can provide the SPDs. We can provide the SPDs. Here in between only we are sending only the data. That data also we are sending through the cable only, one cable only. But whereas earlier, what we are doing, we are sending all analog voltages. We have to use multiple SPDs if you are providing like that to prevent the surge from one place to other place. We have to use a multiple. But if you are providing only one connection, making like this, simply SPDs can be kept at this. If you are transmitting any electrical signal from SM room to relay room, signal SM room to relay room, if you are transmitting any data in the form of electrical signals, there we have to use SPDs at the both the places. Okay. Or otherwise, if you are using non-vital input-output card, if you are placing in the relay room and you are connecting this analog voltage here, every function we have to connect the SPDs there. Every function we have to connect the SPDs here. Here also same operator VD if you are placing in the SM room. To connect this also, either it may be used, we can use a serial communication cable or Ethernet cable. Serial communication cable or Ethernet cable also, that electrical signal only, through electrical means only we are conveying the information. Suppose if you are using OFC, only we are sending the light. We are sending a light. Suppose in case if you are using OFC, such protections are not required. Suppose if you are using this serial communication cable or Ethernet cable, both side SPDs you have to provide. Even in this case also. In this case also we have to require. Okay. This is the component. Suppose here, what is this panel processor? Simple panel processor is a slave unit, or otherwise it is slave unit of EA system. This system consists of non-vital input card, non-vital output card, and one processor card. Panel processor we are using for reading the panel and to convey this panel information status to CPU. Once the CPU after processing, the CPU will send the control signal to the panel processor. The panel processor will drive the indications on the panel. Will drive the indication on the panel. Okay. Now this connection between this both the means here either it may be a communication cable or a OFC use करके आप communicate कर सकता है. You can communicate that. Okay. This is the thing here. Components. What are the components are available in the electronic interlocking system? These are the components are available in the electronic interlocking system. Okay. What we'll do now? The time is okay. We have completed second hour also. Okay. If you have any doubts, you can ask me. We'll continue our discussion tomorrow.
Sir, another 15 minutes left, sir.
No. Oh, sorry. I think, oh, sorry, we're having time also. Sorry. Time is not completed. Okay, we'll continue.
सर
Okay,
बीच
okay.
में थोड़ा हिंदी का भी यूज किया करो.
श्योर यूज करेंगे, हिंदी भी यूज करेंगे, ऐसा
Okay,
प्रॉब्लम
sir.
नहीं है, हिंदी भी यूज करेंगे. ओके,
Okay, sir.
राइट. Okay, no issue. We'll continue our discussion. We have, I thought, 16:30, 16:45 the time is available. Simple, very simple. Here, electronic interlocking system. Maybe you heard the name panel processor. What is panel processor? Panel processor we are using for interfacing the control intercom indication panel and for CPU for interfacing that we are using the panel processor. The panel processor consists of non-vital input cards, non-vital output cards. Okay, right. Here this is the system. This is a system components of electronic interlocking system. Already we know that what are the interface relays we have used. Interface relays used. The interface relays used here. Normally, interface relays used here are for interfacing these signals. We are using these relays, ECRs. For reading the field gear status, we are using this NW gear, RW gear. For interfacing, for reading this LC gate status, we are using these relays, LXPR. And for reading this track, we are using TPR relays. For reading the crank handle status, we are using CHPR relays. For reading the for reading these things, we are using these relays. And for driving the things, for driving the field gears, we are using this interface relays. Okay, like UZR, HHR, HR, DR, we are using. For driving this point, we are using this relays. For driving LC gate, we are using this LXYR relay. For driving the crank handle, we are using the CHYR relay. We are using. Okay, normally, if you see the conventional thing, remaining things all will be treated as a internal. Like here, already we have discussed now that UCR, ASR, UIRs, these are the internals. These are the internal relays. Like many relays are there. Already we have discussed that relays. Okay, 1 second. Simply, this is the operation by conventional panel. Operation by conventional panel. Okay. Simply, this conventional panel, we know that. 1 second. We are using this non-vital input cards. We are using for reading the conventional panel. After reading that conventional panel, the panel status will be sent to the panel processor. It will be sent to the panel processor, and panel processor will communicate this information to the CPU. and CPU after processing the thing here, CPU after processing the thing, then it will deliver the outputs. It will deliver the output. Here, this is the CPU available at the relay room. This will read the field gear status. This will read the field gear status. This will read the panel status. Then after reading these two status, then it will process the logic, and after processing the logic, it will drive the vital output relays. Vital output relays in turn drives the field gears. Once the field gears are driven, again the status will be read to the system back. Once after reading the field gear status, logic will be processed and the outputs on panel will be indicated. This is the diagram how conventional electronic interlocking operations by panel. And this is the thing when you are operating with the dual videos means here inputs are connected to the CPU. Inputs are connected to the CPU. And if you are using dual videos, and here dual videos also, we having one system is online, other system will be there in the offline. Suppose whichever system is in online, that system only will communicate with the processor. System only will communicate the processor. When we are operating using that system, the process will be that will send the status, and it will be that will send the status to the processor. And same time, this processor is reading the input relay status also. After reading the input relay status, this logic will be processed, and after processing the logic, this will drive the vital output relay. Once these vital output relays are driven, and there will be field gears will be operated. Once the field gears are operated, the field gear status will be again indicated through these vital input cards. The vital input card status, when it has a vital input card status again received by the processor, again will process the logic, and this will send this status to the videos. It will send the status to both videos. The response will be sent to the both videos, but it will take the commands from either only one system. Which system is in online, that system only it will take the commands. It will take the commands. Okay, we have seen here what are the input functions, what are the output functions. Normally, the field input functions are track detection indications, point position detection indications, signal detection indications, and interlocked LC gate detection, siding and crank handle control. These are the input functions. That is a field input functions. And panel buttons, knobs, keys. These are the non-vital input functions. Coming to output function, field output functions are signal control relays, point control relays, slot control relays. These we are treating as a field output functions. And non-vital output functions. These are the video indications, alarms, and counters. We are treating this one as a non-vital output functions. Okay. We know that input cards. Input cards we are using for reading the input cards. Also, we having two types. That is vital input cards and vital output cards. Okay, these vital input cards we are using for reading the vital input relay status. We are using these relays. Okay, this relays vital input card, after reading the relay status, it will convey the input status to the CPU card. And panel in non-vital input cards, simply it is reading the non-vital inputs directly, and after reading this non-vital input, that in non-vital input status will be communicated to the CPU. Okay, and the number of inputs to each card will vary make to make. Suppose Ansaldo we having some 16, one vital input card can read 16 inputs, and a non-vital input card can read 32. Okay, like that. If you take other system, the MEDA system, vital input card, you can connect 8 inputs. Non-vital input card, you can connect 64. Like that, it will vary from system to system. Here, every system having output card. The output cards also having two types. That is the non-vital output cards and vital output cards. The vital output cards we are using for driving the vital output release. For driving the output release, simply vital output cards, it will receive the control signal from CPU. After receiving the control signal from CPU, this will energize or de-energize the relay according to the control signal from CPU. According to the control signal from CPU, this will energize or de-energize the thing. And same thing, non-vital output card. Non-vital output card we are using for driving the non-vital outputs on the panel. Non-vital outputs on the panel. Okay, just after receiving the control signal from CPU, non-vital output card, it will drive the indications, or it will withdraw the indications. It will withdraw the indication command from command on video on control com indication panel. Okay, these are non-vital input output card, and we have seen that CPU card. CPU is the CPU central processing unit. It serves as a logic processor. Normally, CPU consists of microprocessor and memory. That memory may be of type RAM, ROM, or EEPROM. Okay, and normally there will be separate EEPROMs will be there. In the EEPROMs, we are only storing this application software and executive software. Simply, ultimately, CPU sends the operations on the panel by the station master through non-vital input cards and reads the field inputs through the vital input cards and executes the according to the application logic available in EEPROMs, and it will drives the field functions. Okay, if the conditions are satisfied, and when the field gears are driven, and according to the yard condition, it will drive the indications on a panel also. It will drive the indications on panel also. These are the components cards used in each system. Normally, general electronic interlocking system, what are the cards used? Okay, and what are the equipment connected to electronic interlocking system? Okay, these are the general discussion on electronic interlocking system. Okay, if you have any doubts, you can ask me. We'll continue tomorrow. Remaining discussion will be continued on tomorrow.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you. Thank you. Thank you, everyone.
Listen.
Yes. Yes, please.